everybody. It's MoNaCo here.
And Milks.
We're doing our second video 2, if you're watching and keeping track.
That'd be page number 6.
And you're going to look at page 6 and go, oh my god, it's a giant blank page. What do I do?
Because you got some writing to do.
Yep, because we want to give you a unit overview for physical behavior of matter.
Sure. Just we want to note on the key ideas and skills you're going to have to learn this entire unit.
This is like objectives, right?
Pretty much.
Okay, gives us a chance to talk about everything we're going to do.
Sure.
First. So let's see. You got to know about STP as a constant for the comparison of behavior of matter. You got to know that it's on reference table A.
Yep. What it is.
Yep. And
0 degrees Celsius and 1 atmosphere.
And if you don't remember those, memorize them. Go look it up on reference table A. I want to see a bullet underneath this in your packet. Bullet, boom. Go look at reference table A.
Sure. And it should also say 0 degrees Celsius and 1 atmosphere.
1 atmosphere, right. So while we're going to be clicking through, and it's going to show up on a screen here as it goes, you've got little bullets to add underneath each one of these as we're talking.
Sure. We are going to completely fill this slide, so try to save yourself some space.
Right. So remember, put a bullet underneath there, reference table A, 0 Celsius, 1 atmosphere.
There you go.
Next.
All right. We need to be able to distinguish between heat, energy, and temperature. Specifically, heat is energy, specifically. And temperature is the measurement or the measure of average kinetic energy. So temperature is basically the measure of heat.
Right.
But they are different.
Right. So at the bullet under here, I want you to say heat not equal to temperature.
Right.
Heat equals energy, temperature's
the measure
motion.
Of it. Yeah. Temperature's the measure of it.
The measure of motion, really, yeah.
It really is, but it's not the actual heat itself.
So you got a bullet. Heat is not equal to temperature. Temperature is measurement of motion.
There you go.
So talking about some phase changes, how to draw and interpret heating and cooling curves. So your bullet here, I want you to write down, you're going to track heat during heating and cooling.
Right, and then we're actually also going to be able to label potential energy and kinetic energy as it relates to that heating or cooling.
So one bullet from each teacher here. 1, track heat as something is heated and cooled.
Yep.
And 2,
show me where the kinetic energy is and where the potential energy is. What's changing?
Okay, cool. I like this. You give me a bullet, I give you a bullet.
Sure.
And everybody writes it down.
If there's 2 bullets,
Hey, if you're doing your work properly, like listening to us guys is over here, you'll have bullets, and that's how we'll know that you're not just tuning us out and bumping tunes.
Seriously.
Because if that's what you're doing, all you're doing is writing down words that aren't going to mean a thing.
Yeah, I got news for you
be
guys.
like,
If you haven't figured it out in this course, that's not doing enough.
It's not even getting started. It's practically not even getting started.
It really isn't. Because when are you relating that to prior knowledge? When are you asking me questions? When are you going anywhere deeper?
If you didn't pay attention to us.
Seriously.
And if you're only writing what's on the screen, you're only getting the tip of the iceberg.
Seriously.
So under kinetic molecular theory, Monacos Bullet is, I want you to abbreviate this to KMT.
Yes.
And what do you want to say about that?
I want to talk about the motion of particles.
Yeah.
The motion of the molecules. So kinetic molecular. How the molecules move.
So Monacos Bullet, abbreviate kinetic molecular theory to KMT.
Yep.
Milks' bullet.
How molecules moving.
Molecules are moving.
Yep.
Okay.
And they're colliding, which is huge.
Yeah, pretty big deal. Let's see. Let's going to describe gases, how they create pressure through collisions, and energy transfer at the atomic level. Monacos Bullet. Gases hit container walls, making pressure. Get it? Gases
exactly
hit container walls, making pressure. As a matter of fact, that's a long one, so Milks is going to say it now too. It's his bullet as well.
Right. Molecules of gases hitting the wall, which creates the pressure.
On a container, yeah.
Right.
Exactly. So that's how it's created. We'll get into that in detail later.
Sure, and when we can manipulate it a little bit even.
Yeah. Describing the behavior of an ideal gas with respect to temperature and pressure. I'll tell him one.
I know what you... Wait,
I'm
going to do Monacos Bullet on this one.
Okay,
Ready?
he's got Monacos Bullet.
High temperature, low pressure.
Okay, and now I'm going to do Milks' bullet for this one. Ideal gas behavior equals high temperature, low pressure. It is that important. You got to know.
Right.
Okay.
And you'll see that that's how it does those postulates for KMT. It satisfies those postulates if it's at those conditions.
Right. Okay, so you got 2 bullets. They were the same in that case.
It's important. Now we're going to be able to use the combined gas law. We talked about that last video, right?
Just the definition of what
Right,
it
we're going
was.
to take all those things and relate them to temperature, pressure, and volume.
Volume for gases.
So if one changes, what happens, and I hold one constant, what happens to the others, and we'll be able to play some games mathematically.
Monacos Bullet here. I'm going to write on the screen and then delete it because I want you to write the equation down.
Oh, I know what it is.
Oh, you do? Milks, write it down. Milks is good. This is Milks and Monacos
Ready?
Bullet.
P1
V1
over T1
equals
P2
V2
P2
over.
T2.
Uh-huh. Oh, and I know what the second bullet here should be.
What was that?
Always in Kelvin degrees.
Ooh, I gotta do that.
Got it.
I gotta do it. Kelvins.
Oh my
measured in
God.
degrees.
In kelvins.
Why do you do
It's
this
a
to me?
degree.
Yeah, why do you do this to me?
Because I do it to you.
Yes, you do.
It's because of reasons.
Yes.
So those are your two bullets under that idea.
Cool. Next, we need to understand the relationship between vapor pressure and boiling. All right, can I define it now or no?
Yeah, let's see if our bullets are the same. My definition bullet, MoNaCo, would say that boiling is when vapor pressure beats atmospheric pressure.
Yeah, or even equals by definition.
Okay.
Once it equals, it's going.
So MoNaCo's bullet is boiling is when vapor pressure beats atmospheric pressure, and Milks' bullet is
When vapor pressure equals atmospheric pressure, because
Right.
it doesn't normally.
right,
The pressure from the air is pushing down on that liquid.
making it a liquid still.
Right. So, last, understand the changes in heat when dealing with a chemical reaction.
In table I. So the bullet I have for this is that delta H, if it's positive, it's endothermic, and if delta H is negative, it's exothermic. I'm going to cover Milk's bullet too because he's tied up right now. So MoNaCo's bullet, delta H, changes in heat, is positive, it's endothermic. When delta H is negative, it's exothermic.
Good. And is there another one?
I'm not sure.
See, oh, that's it.
That's it. Key points of the unit. Now we're going to go into much deeper detail, obviously,
these.
for each one of these key points. And you are going to master these skills, we hope.
Sure.
Yeah. It always starts with watching and listening to us. If you got us on mute right now and you're bumping some tunes, you're not doing it the way we intended you to do it.
Yeah, well, you think about that. In class, you shouldn't be tuning me out when I'm talking.
You should
And what
pay
we
attention
really
to your
just
teacher.
did was, if this thing took 8 minutes or 9 minutes, we just did a 40-minute lecture from class in 8 minutes.
Right.
And you got it, and you can listen to it to each other. You can listen to it over and over and over till you get it.
Oh, and also, if we check your homework and all we see is those words without our MoNaCo and Milk's bullets, I'll know that you really weren't doing what you were supposed to do.
Sure. Yeah. And I can dock your grade, but guess what? How are you going to do on the quizzes and
It
the
starts
tests?
with you,
Yeah.
right? I'm not going to dock your grade because that's your bad, not mine.
Right.
All right.
See you guys.
See ya.